A very good o'clock to all the students. Here I am Amisha, ma'am, your physics teacher. Students, today I am here to start our next topic, that is couple. We have discussed already in our previous video about torque. Okay. See, can a single force generally cause rotation if not hinged at the end? Hinged means fixed. So can a single force cause rotation if it is not hinged, if it is not fixed at the end? Just think. Answer would be easily no. So just remember that torque does not exist single in nature. Okay, torque does not exist single in nature. How? Just consider the example of the step. Okay, we have considered this step. To open the step, what we have to do? We will generally apply both the force. That means a force in this side also and a force in this side also. Here also and here also. If you could imagine, we will apply force in both the direction to open the step. Applying the forces to both the ends, what will happen? Because of these two forces which we have applied, the turning effect occurs, and that turning means what? We are turning na, with the help of both these forces we are turning the step, turning the tap, and this turning is the turning effect, students, and this turning effect causes couple. Okay, here when we have considered the two forces of same magnitude, that is 10 Newton force here and 10 Newton force here. So here if I am applying this force, the line of force could be here, and here when I am applying the force, the line of force could be here. That means both the line of force are not coinciding, therefore the tap will open easily. Okay, always two forces rotate the object. This is my question. Always two forces rotates the object. So to rotate an object, both the forces should be in opposite direction, not in same direction. Here if you could look again, both the two forces should be in opposite direction. If one is moving here, other should move in other direction, and their line of force should not be same, which I have told right now. If it is moving here, the line of force, the second line of force must not be coinciding with it. So let's discuss the case 1. Here I have taken an example of a rod which is hinged in the mid, which is fixed in the mid, and I am applying force in a same direction. Like here I am applying toward this side and here to this side, both in same direction. Will the object rotate, students? Just think. Answer could be no. How? Because the line of action of these forces, see, just look here, because the line of action of these forces could pass through the midpoint or the hinged point. If you also just look here, it will pass through this hinged point or the fixed point, you can say. And if it is passing through the hinged point or the fixed point, you very well know the object will not rotate, as discussed earlier previous videos. Okay, so the turning effect produces by couple is called moment of couple. The turning effect that is produced by couple is called moment of couple, and the turning effect of force is produced, that would be is known as torque. Okay, and here if that is produced by couple, it is called moment of couple, and the turning effect produced by torque is moment of torque. Okay, so can a couple provide rotation in both the direction? This is my next question. Can a couple provide rotation in both the direction? Your answer could be yes. How? See, I have asked here कि couple could provide rotation in both the direction. Just think of a bottle cap. When you are opening that bottle cap, one force you are applying here and one could be here in other direction. Okay, so these both the forces are providing a turning effect, and then that turning effect causes couple, and that couple provides rotation in both the direction. You can also take the example of tap that can be tighten or loosen. Okay, they both provides rotation in both the direction. See, for a couple to act, forces must be equal and in opposite direction. Yes, students? Like, just look here. The two equal and opposite forces not acting on same line. If they are not acting on same line of force, they forms a couple. This is a definition of couple you could see, and you could write as well in your own notebooks that two equal and opposite forces when not acting on the same line forms a couple. See here now, types of movement of couple, students. Let's take the two examples of a steering wheel. Consider two as a steering wheel which are fixed or hinged in the mid. Okay, and here if I am applying one force as here in this direction, other in this, that means it is moving in this direction, students. That is clockwise, it is moving in this direction. Okay, see, one is here, other is here, that means it is rotating clockwise. And let's take the another example of the wheel, that is steering wheel, that is an anti-clockwise rotating. If one force is applied here and other in here, that means it is rotating in this way, students. That is anti-clockwise. Okay, so if forces or couple rotates that object in clockwise direction, then you could understand that it is a negative force. What it is a negative couple, sorry, it is a negative couple. Also, you know very well, when we are discussing about the forces, one if I am taking in this direction, we considered it as a positive. Okay, and opposite to it we'll consider as negative, है ना. Distance as well, one in positive, other one in negative. Similarly, for the moment of couple also, here what we are doing is, if the forces rotates the object, if both the forces, both the couple rotates the object in clockwise direction, then we considered as negative, and if it rotates in anti-clockwise, we considered it to be a positive. Let's consider is now how this couple be calculated. Formula is same as that of torque. What for the torque we are using? Tau is equal to F into D, that is force into distance, and that distance would be between the force and that line of force and pivot. Pivot is what? Fixed end, है ना, as discussed in the previous video. Here it could be for the couple, one force is applied here, other in opposite to it. What we'll see, if the force is applying here, it could be in this direction, and if this force is applying here, it could be in this direction. Let's consider the distance of both the forces to be as, if it is D, then it could also be D. Couple could be force into distance, and that distance could be between both the forces. Both the forces what you are applying in between both of the forces, the distance considered to be as D. So here couple could be F into distance, here is OL and OM. And SI unit remains, student, same as is, it is what? Couple is also a force into distance. The basic difference between torque and couple is that here the distance is considered to be between both the forces, and here that distance could be between the line of force and pivot, that is fixed end. Okay, so therefore, since the formula is same, force into distance, therefore the unit also remains same. That is, for the force we are using Newton, and for the distance we are using meter. So it could be for the couple as well, Newton into meter. Now here let's discuss a question, that is, let us consider a rod which is of uniform length 1 meter. Forces applied vertically upwards and downwards to it of same magnitude, 2 newtons. What could be the moment of couple here? So for the moment of couple, very easy, you know the force, that is 2, same, so just apply 2 here. Distance between both the forces is 1 given, so 2 into 1, that is 2 Newton meter. Consider the other question here. Let's take the example of a steering wheel, where both the forces which are applied is here of 5 newtons in both the case. Okay, and the distance which is given is 0.5 meter. So what could be the couple, moment of couple here? F into D. F into D, that is 0.5 into 5, or 5 into 0.5, it is 2.5 Newton meter. Hope so the topic is clear to you, that is of couple and moment of couple and types of moment of couple, that is clockwise and anti-clockwise. And couple is what? It is a pair. That comes, things which are coming in pair. Here forces are coming in pair. Okay, therefore it is a couple. Okay, thank you students, do watch the video.